Hi everyone, my name is Mathieu Muller and I'm a product manager in high-end graphics. I'm based in Paris and I'm talking to you from here now, and I will talk about artist-centric workflows and usage for high-end rendering. So artists have created visually and emotionally stunning content for the past 15 years with Unity. But for most of that period of time, the features that I will talk about were actually not part of our product. It's because art is not about features, but it's about inspiration, possibilities, and constraints. Inspiration for design or visual style. For example, Alto's Adventure and Monument Valley use the high resolution of the mobile phone and the high quality of these screens to create beautiful and very sleek interactive experiences. Some other people were driven to create new form of storytelling. So for example, Her Story is an example I always give, which is an interactive movie on multiple platforms. Or Firewatch, which is a beautiful walking simulator by Campo Santo. Another inspiration could be the fact that you're doing things in a way and you want to change your industry practices. You think that using a real-time engine can change things. Michael Boluffer made Mr. Carton, you can see it on the bottom right, and it was the first web series, animated web series created with a real-time engine. He wanted to gain independence, work from his home with just a computer and with a very well-trained team to still be able to do 3D graphics without a render farm or render pipeline. Art is also possibilities. It's the fact that you can reach new audiences, new platforms. For example, Baobab Studio, that you can see on the bottom left, they created, they are coming from, a lot of them are coming from DreamWorks, and they wanted to tell stories in a different way, and jump on the VR trend and started to create a lot of content there. Or in the middle, some artists created this beautiful installation on the Boston Children's Hospital, and for the kids while they are waiting. Possibilities are also features. So when we implement new features or we give new capabilities and new possibilities, but sometimes it can be a constraint because a feature has multiple implementation, and sometimes our implementation will not match what you expect, and that's where usually the extensibility of our platform comes to the rescue with the help of the community and asset store, and usually you're able to find different implementation for the same thing, which is coming also with its own constraint, because sometimes it won't reach every platforms, but that's also the advantage. Which takes us to the last point of creativity, the last ingredient, which is the constraint. And especially with real-time development and real-time applications, multi-platform is a constraint. If you want to have a large user reach, you will need to maybe narrow down your vision, review your budget, and maybe find new team skills. Hardware have made immense progress in the past years, both in desktop, as you can see on the top, and both in mobile, to create amazing graphics. But at the same time, your user audience might not have all the same hardware, which is taking us to how Unity is shaped today. So to offer you both high-end graphics and also still have flexibility and cross-platform development, one key element was the rendering loop. We have separated the rendering from the core of Unity with what we call scriptable render pipeline to enable people to create their own render pipeline, but also for us to provide two different architecture, the universal render pipeline and the high-definition render pipeline. So you can look now at Unity through two doors. And to enter these doors, you need a key. And this key has 4 parameters. The rendering type that you expect, the target platforms, if you want built-in features, or full versus full customizability, or what kind of hardware optimizations you're looking for. So the red key opens the universal render pipeline doors. And if you have this red key, it means that you're doing a 2D content or a 3D content, but know that you will have limited dynamic lights. But at the same time, you will be able to highly customize the lighting. It means that you do something on mobile AR or mobile VR, but not only. Also, you can do also cross-platform development all the way through consoles. If you enter this door, know that you will have limited built-in high-end graphics features and materials, but maximum customization of the pipeline via C# and shaders. Know also that the focus of URP is optimization on CPU and non-compute based GPU optimizations, so that you can reach a maximum range of platforms. The golden key, on the opposite, opens a high-definition render pipeline door, which means that you're looking at 3D physical-based rendering, but also lighting, so physical units, and that you can have many dynamic lights. It means also that you're targeting high-end platforms like desktop, consoles, pixel streaming, or that you're doing offline rendering, for example, for cinematic snapshots, high-end snapshots of film. You have, once you get there, you will have integrated high-end graphics features and workflows which work well together, but more complex, deep customization of the code, of the render loop. And the code will be optimized for GPUs. So let's go through a quiz to see some examples of production and see which pipeline is the right one. So let's start with Omelette and Yogurt. I really love the name of this user. And he's an indie dev working on a shooter set on a mysterious island. And as you can see, he's looking at photoreal. Clearly, he's looking at high-end platforms. He seems to be alone working on this, so he needs to have a lot of the features made together. So clearly, this is a typical choice for high definition render pipeline. If you follow him, you will see that he has done a lot of customizations too, like his own water shaders, his raindrops on weapons. He's using contact shadows to still have higher definition asset, but good performances on shadows. He's using decals for the water puddles, created a brush to create the flows on the water, and create custom shaders to do dynamic vegetation. Another example here is Sonder. Sonder is really a beautiful movie about the fact to break up with somebody. It was created by Nesnum in 2018, and Nesnum has been working for more than 13 years as a director and animator at Pixar, at Google, Oculus Studio, and in this industry and with this kind of graphics, every single pixel needs to match a color script. So it's very important to be able to override the lighting equations for artistic reasons. You need to control the color of the pixels in shadows, in highlights, in rim lights. So for this, clearly, built-in universal render pipeline is a right choice. I actually said built-in because it was created using Tuni Colors Pro 2, an asset store created by Jean Moreno, who became actually part of the project, and this asset is now available on URP. ArcViz. So you see here, you already have the answer, HDRP. The reasons are, again, advanced materials. So you have other kind of materials. You have also advanced shadows, advanced reflections, like planar reflections, screen space reflections. You will also get access to all the ray tracing features, which is very important. Sometimes, for example, if you have complex glass, you will be able to actually totally fall back on ray tracing to render them accurately. So clearly, that's HDRP if you target high-end platforms. On this other content, The Carrier by Ivy Studio, it's a trailer of a 6-episode mini TV series, and Ivy Studio, they wanted to have high quality graphics, almost like feature film quality graphics, And at the same time, it's a small studio, so they need to have all the features they need together, and they wanted to really have a unique style to it. So one could think that it's Universal Render Pipeline because of the stylization, but actually here you can see that most of the work of the stylization is done at the texture level, at the shader level, and the way it uses the colors and the post-process effects. So high definition render pipeline is good for that, and it was made with this. We're back to ArcViz, and you can see now a VR experience, and again you think you have your answer with HDRP VR. So yes, HDRP supports most of its features in VR. So volumetrics, most of the materials and lights. You might have to tweak down a bit some effects for performance reasons, but you get access to all the features. However, this is only for high-end desktops, so for desktop VR. If you're looking at mobile-based VR like Oculus Quest, then I would recommend going to the Universal Render Pipeline. And know that, again, Universal Render Pipeline is not for bad graphics, but it's really also for high-end graphics, but with less features and with an architecture which is more appropriate to lower-end devices. We'll talk more about this after. So here we have a car configurator in AR. So Parth Anand from India is making a lot of AR and VR experiences. And here, again, we are in the high-end graphics world, but URP is not viable on mobile platforms right now. So definitely, I recommend URP. And again, I want to iterate on the fact that high-end graphics are important for us also on mobile. So for example, we are porting the code material to URP to enable this kind of experiences out of the box with Universal Render Pipeline. Another animated film. It's a series of 4 episodes about PSA by Lego. It was created by Pure Imagination Studios with Zebu Animation in India. And as you can see, the goal was to create high-end quality short films, very photoreal, in the spirit of the Lego movies. And for this, no question, you're doing offline and you want high-end graphics, so it's like you can go directly with high-end definition render pipeline. Back to ArcViz again. You can see here, again, ArcViz Pro assets, so you can find them on the asset store with the mobile version. So again, mobile is more appropriate with Universal Render Pipeline, and actually pretty high-end graphics are possible with it. Here, Arnold Wong is a 3D race car artist. So a race car artist or a car artist, he wants to have photoreal visuals, but at the same time interactivity, so that the car can be explored from every point of view, configured in terms of materials and colors, but also maybe being driven. And for this, again, high definition render pipeline is a way to go. Reason is very advanced materials, like for example for a car, the stacklit material of HDRP, which allows to simulate the different layers of coating that you would find on a car. So stacklit allows to mix different layers, which are mixing, for example, anisotropy, subsurface scattering, haze in the same material, and iridescence. So this is only available on high definition render pipeline. Also the advanced management of transparency, which is again very important for the windows. Also the area lights, which is a typical way to light a car in a showroom, and of course ray tracing, so that you can really represent correctly all the complex reflections, refractions, shadows and ambient occlusions on a car. Digital human. So here, Hyung Il Kim, I'm not sure if I pronounce it well, sorry for that. He is making a real-time digital human, Sua, and he wants her to be famous. So Sua needs to be controlled in real time, but look like a human. So for a digital human, we again recommend high definition render pipeline. It contains all the shaders already built in for that, the eye shaders, which is new in 2020.2, hair shaders, which manages properly transparency for hair cards, with a KGAK shader for hair shading, advanced shadows and contact shadows, and especially ray tracing, which was used on this character to represent the complex lighting that you have on the face, with the bounce on the nose and the occlusions everywhere that you get. Also, Hyung Il Kim used a plugin by Deform Dynamics to be able to simulate in real time very high-end close simulation. As you can see on the left, I'm going to play it back again. So I also recommend checking the Heretic Digital Human package, which showcases teeth, eyes, like you will have a lot of samples that you can reuse from there. It also showcases the runtime rigging of the body using our runtime rigging package that we'll talk about later. And lastly, another question on this one. So Moon Studios, they did Ori and the Blind Forest a few years ago with beautiful, stunning visuals. They customized a lot of our engine, and which was reaching some limitations of what really you can customize with Unity. With scriptable render pipeline, they wanted to go further, and neither URP or HDRP was really appropriate for this type between 2D and 3D. So for them, it was about creating their own scriptable render pipeline. So they did this, and to be able to run with beautiful graphics on Nintendo Switch at 60 frames per second. So we're done with the quiz, and from now on, I will assume that we take the high definition render pipeline door, because we don't have much time on this presentation to cover URP also, but a lot of the artist-centric workflows are actually common between two. So if you enter this door, in practice, it's just you don't need a real key. You just install 2020.2 and create a new project. And I would recommend using the high definition render pipeline template as a starting point. We have a brand new one, which is beautiful, showing three kinds of lighting conditions: indoor, outdoor, and indoor with artificial lights, and this room in the middle, which has a mix of which is lit by the exterior lighting. It also showcases a lot of features of HDRP, how to set up the materials, the volumetric lights, VFX graph particles, the cookies for the lights, the decals for the light pedals, and so on. So now you just have to bring your assets in, which is importing your objects. We support a lot of digital content creation tools, both in the entertainment world, I would say, Blender, Maya, Max, Cinema 4D, Houdini, and so on, Substance, Modo, but also even on the industrial work with Revit, Navisworks, SketchUp, and Rhino. The industrial part, we manage it through a new product called Unity Reflect, which allows to create a kind of live link between Unity and these products. And also, I just want to mention, because I'm very happy for that we've joined the Blender Foundation Development Fund, as Patreon, members. So it's great. I'm very happy that we're part of this beautiful project. And so many times you will exchange your assets with an intermediate format. So FBX is the most production proven format that we have. It has been used for years, and we have actually improved it a lot in the past 2-3 years with a partnership with Autodesk. We have access to the FBX source code. We could fix something, could improve a lot of things on our side also. So now you can import like meshes, of course, and animations, skeletal animations, and blend shapes, but also lights, cameras, constraints, custom data, activations. So there is actually a lot of things that you can import through FBX now. We have also an Alembic package, which is nice to bring simulations in. So know that it's pretty heavy to play back an Alembic, so it's mostly made for high-end platforms. It can be also useful if you want to render a character with a complex rig that you could not transform through skeletal rigging and skinning. Or blend shapes, so you could directly import it with Alembic. We have also USD as preview package. We can import OBJ and a bunch of formats like point clouds, for example, formats with a partner, Pixies, which has a plugin. You can check it out on our website. So sometimes you don't want to go through an intermediate format, or you want to directly link Unity with your have a more direct bridge with your DCC. So already a lot of them have created their own bridge, like Cineware for Cinema 4D, Session Sync for Houdini, or Modo Bridge for Modo. But we also have a package called Mesh Sync, which allows to live link with Maya, Max Blender, Motion Builder, which can be useful if you do mocap, or Meta Sequoia. So once your assets are in, you need to do the look development, and most of the time the look development has to be done on Unity side. However, we support some material formats recently. This year we added support for 3ds Max physical material, Arnold standard surface, and Autodesk Interactive. If you use USD, you can bring preview surface. We also have support for AXF, which are measured material formats. So for industry applications, you can directly bring something which was scanned, for example. We have a new API also, if you want to create your own pipeline and hook. At the moment, we will associate the description of your asset from the DCC and the material in Unity. One thing I want to mention, that right now in HDRP, we are packing some maps together for efficiency reasons, and sometimes it's not practical on the workflow. It's something we would like to improve. So if you have different maps for all the different aspects of your material, one tip is to use the standard material, so it will be pink, but you will be able to associate each map separately, and then upgrade it to HDRP. We have a menu for that directly in the editor, and this will automatically do the packing for you. If you have not transferred the material from DCC with these techniques, and if you want to go further, one good shortcut is to use the HDRP material samples. So if you go on the package manager, you will see that you can download some material samples, and which are already set up for you. You can reuse them and maybe tweak them if you want even to customize them. It's pretty good. You have eyes and cloth and different fabrics, different metals, different woods, glasses, and so on. You can also use our Unity Measured Materials library, which is available for both URP and HDRP. So this library we made it ourselves, scanning a lot of different materials with real things. And if you still want to customize your material, you can use shader graph. So typically for water or some animated or stylized effects. For your look development, we have an HDRP look dev tool directly in the editor, where you can compare your object with different environments or with different debugging modes. There are no HDRI included in this tool, so you can download the HDRI Unity pack on the asset store. And also know that in 2020.2 HDRP 10, the HDRI has an option now where it can generate a backplate for you, so that it generates actually a plane in the HDRI projecting the bottom texture, so that you can directly place your assets, and you will receive shadows and and ambient occlusion. So it's a very nice way to very quickly also do look dev in Unity. Then the next step is you want to build your environment. So you can create a terrain, for example, on the back in Unity. We have a lot of new terrain tools. Again, it's available as a package on the package manager with great brushes. For example, there is one with a hydraulic erosion, but many other tools are available. You can use vegetation and scan data. You have all the shaders needed for vegetation rendering, and also for scan data, the layered lead shader will be very interesting to be able to blend, for example, the bottom of let's say a big rock which was on the ground. You can use a special layer for the bottom part and project it in world space instead of UV space, so that it can blend nicely with the ground texture. You might use Houdini and the Unity Houdini engine if you want to do procedural generation of your worlds. You can follow this guy who's made good stuff, I think, there. And use decals also when you use scan data, for example. It's nice to break the repetition with some imperfections. And again, we have very advanced decals in Unity. Then you might want to get to a bit of a stylized look, as we mentioned before. HDRP is not great if you want to stylize lighting, but you can still do some stylization with it using shader graph if you want to do stylization at the object level. You can inject custom passes at different places of the pipeline, and using this way you will keep the coherency of your of what you inject through the different steps of the pipeline. And also do custom post-process, as you see here, to do a full frame stylization of your project. Two references here: RealToon, which is an asset on the asset store. You can see it here running, which creates anime shading in HDRP, and I think it's available also on URP. And UTS2, which is Unity Chan, which was available for built-in render pipeline and which has been also ported to URP and HDRP now. It's provided by Unity Japan. Then you want to light your content. So for example, actually this is very important because this is where URP and HDRP are very different. So HD render pipeline uses physical lights. So physical light units, sorry. And sometimes it's not easy to use that if you're not used to. If you're from the CG world, maybe you're more used to that. We actually changed the UX to make it easier for a user to understand and apprehend with basically integrating these icons directly in the UX, so that you can choose a value which corresponds to something you can know in the real life, like if it's a cloudy day for the exposure, or if it's an interior light or a candle intensity, or the color temperature of these different lights. We also support IES lights, so for the light cookies you don't have to generate your own cookies anymore. You can directly use IES profiles, as you can see on the video here. You can download the IES from many actually light manufacturers. And you have access to a lot of lights, as you can see on the right, a lot of light options with spotlight box and spotlight pyramid and rectangle lights, tube lights, and so on. We have also a lot of advanced shadows control, hard, soft. We can even tint the shadows in HDRP. We have contact and micro shadows to get the beautiful details, shadow details that you have at the micro level or contact level, which is great for vegetation. Screen space ambient occlusion. We have also a caching system which allows you to not update the shadows all the time, or all the shadow cascade all the time. And most of these effects are also available on the ray trace version. So for example, with ray tracing you will be able to have colored shadows if you want to have like church glasses and so on. And of course, lighting is also about global illumination, so which is usually baked on a real-time engine. So either with a CPU baker, we have a CPU baker or a GPU one. Know that the GPU one you can improve performances if you stop the refresh of the scene view, so that you can keep some power to do your light map baking. And also, as you can see on this video, we have introduced SSGI, which is screen space global illumination, which allows to compute global illumination in real time, and it's very appropriate for the small scenes like a configurator or smaller scenes. You want to have reflections and refractions, so using reflection probes, we have a lot of parameters again to manage reflection probes and refraction probes with different blending modes on every axis. Planar reflections, which have improved recently with a more physical representation of them, so that it's pretty sharp, close to the reflected objects, and then gets blurry. Screen space reflections, which now support also transparent materials, as you can see on the videos, and of course ray trace reflections to get perfect reflections on the most complicated situations. And then finally, you will composite your work using post-processing with tone mapping and color grading tools. We have also added a render pass API, which allows to export the render passes, but also use them for your own effects. For example, we have a new tool called the Compositor in HDRP, which allows to do camera stacking and layer-based composition. So what it does, for example, you can associate a different settings to different layers. So for example, here the video has no anti-aliasing and has only a post-processing volume, so that you can do color correction, while the CG elements are actually have TAA enabled and a volume with lens distortion, depth of field, and motion blur, so that it actually matches the camera effects. And then the two layers are composited together with a shader graph. You could also render one layer into a proxy volume, so that it reflects itself in the virtual world, for example. Or you can use it also for green screens. So now it's time you have your assets in, and compared to the offline world, you can also give them life and interactions. So the first step is to film them. So we have a physical camera, which allows to import the settings from your DCC. It's also the place where you will animate the camera, because it can control the post-processing. So for example, exposure and depth can be controlled by the physical camera. Note that we have a new physical depth of field, which is based on our path tracer, which also supports depth of field, and we use it as a ground truth reference to implement this physical depth. It's pretty expensive in terms of performance, but it's more physical. And exposure is very important too, because if you use physical units, then it means that you have to think about the camera as a real camera, where you have to set up the exposure correctly. So you can actually use the physical camera parameters like ISO and aperture, which will automatically control the exposure. You can have a manual mode, an automatic mode, and a new automatic mode, which is histogram, which uses different histograms. You can actually debug them, as you can see on the video, to have more advanced management of exposure on a dynamic, like automatic exposure on the scene. Finally, your camera. Sometimes you want to use it for cinematics, and sometimes you want a procedural camera, so that it follows the player or it reacts to the different moment of your experience. And Cinemachine is for both cases. For example, right now there is no focus distance on the physical camera, so that's something we're considering adding. But right now you have to use a Cinemachine camera so that it exposes the focus distance, and then you can animate it from there. So then, of course, giving life means animation. So you can import keyframes, bones, blend shapes. I see here in the middle, we support now up to 32 bone influence per vertex. So you can actually get an animation rig into Unity with pretty good fidelity. But to enable this, you need to go in the quality settings, on the import settings, and you can also configure it per skin mesh renderer. We have a runtime rigging package, which allows to generate a rig based on the rig that you created on your DCC. And using this rig, you will be able to animate to do some posing on top of the animation, so you can actually transfer the motion to the runtime rig, or you can override the animation with the runtime rigging. So for example, a look at or adjust the hand or feet positions, or you can do some procedural animations, for example a tail on a character or some clothes on top of your animations. Another way to animate or to give life is to use shader graph. So for example, the wind or dynamic vegetation, that's the place where you would do this. And of course you can animate like most parameters in Unity using the animation window or using timeline if you want to synchronize multiple animations or sequence them in time. Then to give life again, you can simulate. So for particles, we have two systems, VFX Graph, which is for compute compatible devices, so more for high-end devices, and which is a node-based system, so it looks like a bit like the Houdini philosophy. And we also have Shuriken, which is still maintained and which is actually a great asset, which is optimized for CPU and which is running on every platform. You can see a lot of examples everywhere running on Shuriken. Like here, for example, Crypto 289 realistic effect packed on the asset store. Check that, it looks really great. For simulation, you can use physics, like the Unity physics or actually physics, which is integrated in Unity. So for example, you have close simulation, which is good for secondary character animation. You can bring simulation directly with Alembic. And there are some interesting plugins. We mentioned Deform Dynamics for super high-end simulation. It's quite expensive, but it looks really great. Or OBClose also, which is another real-time simulation, a physics simulation engine. Volumetrics also are now part of HDRP to do atmospheric scattering, fog volumes, have volumetric shadows. You can also import some or even generate density volumes so that you have some moving clouds. And by the way, we now support 3D texture import directly in Unity, so you can just import 3D textures and you have different ways to visualize them and to reuse them either in volumetrics or on VFX Graph. And then finally, you might want to create something which is interactive. And if you could use C#, it's don't discard any time. The coding is a great way to do procedural things and interactive things, and you have a lot of tutorials online to learn. But also visual scripting is another initiative, another way to work. And we actually acquired Bolt, which has been around for many years, and it's production proven, and it's now available for all users for free. You could also use physics, for example, use a car or plane controller and just directly, or character controller, directly be able to control your assets. Use a UI to do some parameterization from the user, like car configurator or something like this. And also we have more and more events and signals in a lot of components, like timeline now, so that you can trigger events and automatically you can just drag and drop another component and say what is the consequence of this event. And you have this also on the VFX Graph. And now you've done all that, and you can share your creation. So to share the creation, you can record and export. So if you want to do an animated film or a trailer or high-end like snapshots, we actually support video export with ProRes now built in. Image sequence, AOVs if you want to do external compositing. For example, if you want to do backgrounds on a movie, you can do that. You can export audio so that you can have audio back down after, and also you can even export the assets that you've created or animated in Unity. Typical example is you create a virtual camera, and then you want to export this virtual camera back to, for example, a film pipeline. Note that path tracing to render high quality, like full frame path trace images is experimental, but support almost every HDRP materials now. Depth of field, fog, so not scattering now, but we're working on that. And we are working on an integration in Recorder so that you will be able to, when you create an animatic, you will be able to actually record a full path traced version of that. And of course, maybe you want to build an application so that people can install it and play and interact in desktop VR consoles. If you want to reach more users, still with the top high-end graphics, you can stream, which is a new thing, like Google Stadia or Amazon offer the services for gaming. But we have our own service called Unity Cloud Streaming, which is called Furious for Unity for cloud streaming. And you can directly install your high-end app there, and which will be launched when somebody connects, and people will be able to interact with super high-end graphics even on their mobile. We also have a pixel streaming package which allows to do the same thing on more locally, I would say. And then, lastly, if your project goes well, if you're created something that inspired others and your project becomes something big, you probably want to expand your team. A first step is to just enable Unity Teams directly accessible from the Unity editor. It will allow you to upload your project on the cloud and save all the iterations, revert back if you break something. It's actually useful even if you're alone. It can automatically generate applications on different platforms so that you don't have to open your different devices or computers so that you do special builds. It does it for you, and then you receive a message and you're directly able to install it on each device. If you want, like Unity Teams right now is made for small teams, I would say. But if you want to scale, there are many different options, and we actually acquired a company again called Plastic SC, who is doing Plastic SCM, which has a lot of features to do a lot of branching, local or distributed source control. There are merging options built in. There are some artist tools and so on. But you can also use support for large binary files, for example. But also you can use other solutions like Perforce, Git, or others. To avoid conflicts, just remember to use nested prefabs and different scenes and different assets, for example, if you use different timelines, so that each one works on his own asset and you don't have to merging problems at some point. And then also note that we have added Python for Unity Editor as a preview package, and which allowed to create a plugin for Autodesk Shotgun, so for assets, art assets project and pipeline management. And also F-Track is proposing a plugin now based on this Unity Python for Unity Editor. So that's all for me. Thank you for spending the morning or the evening or whatever time with me. You can find me on Twitter at the FKey. And if you want to learn more, I recommend seeing this talk, Achieving High Fidelity Graphics for Games, with the HDR on the pipeline. And there is also a link to the webinar, so I hope you have access to all that. So for the Q&A, I received some questions before that, so let me check that. Okay, so do you have any creative plan to apply Unity engine to the specific industry that the Unity has not attempted? So you've seen that we are actually like HDR on the pipeline is about photorealism, and it actually goes in every domain that like CG, 3D photoreal graphics are going, and we've seen ArcViz and film or automotive, but actually we're expanding to a lot of different areas now. We have some users in the medical industry who are using Unity for surgery simulation, for example. We see really usage on every places, so it's very exciting to see the possibilities. Training also, for example, training on any kind of industry, you can do that now with digital avatars and pixel streaming, for example. Now you have access to training on any device with super high-end quality. Alembic, another question. Alembic requires a lot of resources. Some things had to be abandoned for optimization. Is there any other effective way? So yes, Alembic is by definition something quite expensive. We always have this in mind to create an intermediate cache so that it would be much faster, for Alembic playback. But we have not tackled it, but right now. But maybe it could come. Yes. So another effective way is, I would say, for characters, for example, I would really recommend trying to get your rig, to get an export of your character, for example, in FBX, because it's much more lightweight. For simulations, we don't have much other ways to do it right now. Can I get a job? I don't know. You can apply on our website, I would say. We are making light casual puzzle games for mobile platform. I want to use post-process without compromising performance. What's a good way? What do I need to be careful about? So I think the first thing is to choose the right post-processing. We have different ones. We have post-process V2 for the built-in render pipeline, and then now each render pipeline comes with its own optimized post-process. So be sure that if you're using URP or HDRP, don't use the post-processing V2. And then I would say that be careful with the kind. Some post-process are more expensive than other ones. So yeah, maybe tweak them, focus on these ones, and sometimes you can find other workarounds for them, for some of them. Would you use, another question, will you use Unity HDRP if you had a project to produce high quality videos or images, or are you going to use another pre-render? So yes, definitely we can see a lot of projects which are using Unity or real-time in general to create videos or images, so definitely consider doing this. Especially now with the feature set of HDRP and the fact that we have a recorder which is built in. We have also accumulation motion blur which will come. Check the different things that we've made on our website. We have Disney, who has made Baymax Dreams and more episodes recently. And it's actually working, I think, pretty well in production now. We have also Treasure Trackers, which is an entire season with 52 episodes for TV, which has been made with all the backgrounds made in Unity HDRP. So yes, consider using this definitely. Is there a way to visualize multiple renderers by randomly placing them? I'm not sure if I understand this one. So you right now it's we don't support switching render pipeline in real time. We actually kicked off a team for cross pipeline, dedicated to cross pipeline. So and the first goal is to be able to manage the two render pipelines at the same time, if that's a question, in the same project, and being able to switch. But we are still defining exactly what's the strategy here. One thing we want is really that you're able to have one project targeting the two render pipelines, but maybe making two different builds. And the second thing we know is we really want to have more coherency between HDRP and URP. Question number 9, is there a way to visualize multiple renderers by randomly placing... it was the one. Number 10, could you please tell the developer how to easily get the graphics skill to get good quality results? So yes, definitely there is a ramp up when using real-time engine. It's a bit more similar to the way of working if you come from the CG world. We have a lot of things which are built in, so it's also much more easier than it used to be. However, there is a ramp up at the beginning, especially when you set up, there are many options in HDRP. And sometimes you need to enable them so that you can see what you're doing. So we're trying to to address this complexities, this initial complexity. So don't be disappointed at the beginning. There are some settings, and they are here because we want them to be powerful, so that you can really adapt the settings, and it will automatically adapt the performances for you. So that it's made for good reasons, but at the beginning it can be destabilizing. And also the volume system, the fact that you can override some parameters with the volume, which is very typical for a game engine, because sometimes you want some parameters to be override depending on where the user is. So that's why it's a volume, even if sometimes it's a global volume. And actually we have a new debugger in the debug menu of HDRP, so that you understand better who is overriding what. And especially what is complicated with volumes is the fact that by default you have already a volume. So sometimes you have things which are turned on that you don't know they are turned on. So if you go on the preferences, you can see what is this default volume, and if you want, you can put an empty volume there so that you're sure you don't have anything set up by default. And how can I optimize online and offline co-work? So as I was mentioning, be sure that it's very clear how you work, and that each one who is working works on his own asset. So you have a kind of integrator who is sure that he creates prefabs for each one to work on, and then each one is just committing his own prefab so that it's easier to collaborate. And yes, you have now a lot of options to do source control and even asset management. Okay, thanks a lot for your day. It was a pleasure, and I hope to see you in real life one of these days. Bye bye.